What's up, Blooners? If you've been watching my content on this channel, then you're familiar with my involvement in the BTD modding and hacking communities. It has been over a year since my last video, and quite a lot has happened within that time. Most notably, I have recently made the decision to pause my work on NKHook 5, which is why I haven't made any new updates or videos on it. The entire year was filled with uncertainty as to if continuing the project would be viable for the scope I wish to achieve. Ultimately, within the last few months, I've decided that it was simply too ambitious for me to do alone, so instead I've decided to take up an even more ambitious project: rewrite BTD5 entirely from scratch using the Godot game engine. In terms of modding, BTD5 has a few bugs, minor performance issues, and is missing a lot of quality of life features like per-map saves. Many of these things are issues I ultimately wanted to solve with NKHook 5, but it's just too difficult and time-consuming for me to do alone. It eventually came to a point where simply recreating the game myself seemed a lot more feasible than actually working with the real game itself. Before I started implementing the game in Godot, I needed to become more familiar with the game's assets. I already had become extremely familiar with this from NKHook 5, but if you've never done any BTD5 modding before, there are some things to really think about. The first problem to solve is actually reading the various asset formats used by the game. Most of the files are actually pretty common in typical file types like PNG or JPEG for images, but there are some strange and uncommon file types such as JPNG, an image format containing both JPEG data for color information and PNG data for transparency information. There's also the JET file, which is really just a password-protected zip file containing the JSON documents that define things like towers and balloons and other gameplay-related information. It also contains some things for defining maps and screens. I decided that in order to load these uncommon formats that Godot doesn't already support, I would write some C# code since it is capable of being used for more technical applications like this, while still being able to be flexible and easier to write. If you guys want me to make a video going into detail on how these formats are actually made and how they work, just let me know in the comments. The next problem to solve is that BTD5 and other new framework-based games use something called compound sprites to compose sprites together into objects that can be animated. Things like tower sprites, bloom sprites, and so on are all compound sprites, but this also includes things like the intro animation, the layout of various GUIs and menus within the game, and even the splash screen itself. Implementing compound sprites is probably one of the most important things to achieve in this project since they serve as the groundwork for pretty much everything related to the game's visuals. There are a few key aspects about compound sprite files that need to be considered when implementing them in Godot. Firstly, there are the actors, which define the initial state of the sprites, and after that is the stage options, which defines the length of the animation in seconds, what sprites are used, and what texture they're from. In case you didn't know, the game stores multiple sprites inside of a single texture so that the engine can more efficiently render them, and Godot can also leverage this, which I'll talk about when it comes time to actually optimizing. But finally there's the timeline section, which defines the various different states of the actors at different points in time in the animation. Game developers using Godot have a wide range of options available in terms of what programming language to actually use. The engine itself is open source, so if you really wanted to go out of your way to add support for another programming language, you easily could. Out of the box though, Godot supports GD scripts and C# and optionally C++ as well. While BTD5 itself is written entirely in C++, I ultimately chose to use C# for the rewrite since it is a lot easier to work with and I could get a lot more done in a shorter amount of time than if I use C++. This does come at the expense of C# being a little slower, but the language still does have some options for optimizations. When I first started writing the compound sprite renderer, I was trying to use GDScript for everything since I figured it'd be the easiest to work with and potentially a little bit quicker than C# due to how integrated it is with the engine itself. I also chose to rewrite it in C# as well to compare the performance. And I noticed that using C# resulted in approximately 30 more frames per second when rendering the main menu sprite, so I chose to stick with it for the remainder of the project. To actually load the compound sprite files into Godot, I first defined a few classes to represent the JSON data found in the files, things like the actor state, the alignment and flip values, different actor types, and so on. I created a class called Timeline Interpolator to represent the various stages of the animations for each individual actor in the sprite, and created a sparse list class to make the sprite lookups more efficient. The compound sprite class extends off the Node 2D class from Godot, so it could behave as an object in the scene, and inside that class I defined some more functions for loading the actual JSON data. The Timeline Interpolator class then has a getState for UID function, which then takes in a UID and does some processing to calculate the state for the actor with that UID. Putting this all together, we can now drag the compound sprite script onto a Node 2D in Godot and load it into the game. So, this is the current state of the BTD5 rewritten project. If you like what you saw in this video and want to see more, be sure to subscribe or even join the Discord server. I'll have a link for it in the description. I'll also probably be making a lot more videos showing the progress of this project over time, and if you know how to use Godot and want to help me out, the code is open source available on GitHub, so pull requests are always welcome. Additionally, I would suggest contacting me, since I currently have not made a roadmap for the project and I'm kind of just winging it. But yeah, I hope you enjoyed the video, and thanks for watching.